All right, looks like our numbers are stabilizing, so let's go ahead and get started. Thanks everyone who is joining us today. Welcome to today's CNCF webinar on Istio, Security of the Mesh and Security in the Mesh. I'm Caitlin Barnard, Marketing Manager at CNCF, and then I'll be helping to moderate today's webinar. I'd like to welcome today's presenter, Gadi Nao, who's the CTO and co-founder at Allfeed. So I just want to go over a few housekeeping items before we get started. During the webinar, you are not able to speak as an attendee. So if you have a question, there is a Q&A box at the bottom of your screen. Please feel free to drop them in there, and then we're going to save those to the end and get to as many as we can. The session is also being recorded, and that will be sent out to you all afterwards along with the link to the presentation. So with that, I'll hand it over to Gadi to kick off today's presentation.
Thank you very much, Caitlin, and thank you for the CNCF for hosting me for this webinar. So a little bit briefly about myself. My name is Gadi Nao. I'm the CTO of Allfeed. I'm based out of Tel Aviv, Israel. I try to enjoy skateboarding as this picture kind of hints, and I do try to stay alive and hopefully do that until I cannot walk. My background basically goes back to the traditional security vendor. I spent many years at Checkpoint building IPS and firewalls, and then moved to a startup that basically built distributed firewalls for the hypervisor, and spent a few more years at Juniper Networks around SDN. In today's webinar, we are going to talk about security in the mesh and security of the mesh, and kind of walk through the different challenges around the security aspects and the operational aspects of the service mesh, and challenges around what makes sense from a security standpoint, what makes sense from the challenges of operating the mesh continuously around actual deployments and the underlying infrastructure that drives that, and take a few examples of how actually we can today, leveraging some bypass techniques to actually go through the mesh without relying on the security infrastructure in the mesh. So when we are trying to kind of see the cloud native application stack and the new stack, we often refer to Istio as kind of the service mesh infrastructure that is baked on top of Kubernetes, even though service mesh on the promise around that targets use cases that spans virtual machines and bare metals. Presently today, we see, at least from the customers that we are facing, a lot of interest around operating Istio on top of Kubernetes, and these systems are extremely kind of working together in a very clean and elegant way. And in the future, incorporating functions or function as a service on top of the service mesh is something that brings in, beyond just the operational model, a programming model that is strongly rely on the basic construct that Istio basically brings into the mix. And when it comes to kind of the separation of concerns and duties around those, that technology stack, we are looking at Kubernetes as kind of the primitives for deploying and managing container workload at scale, with the ability to kind of scale in, scale out, and concepts around stateful applications and deploying them across multiple clusters, scaling the cluster itself and operating that in kind of a secure and uniform way. Kubernetes by itself is an extremely powerful system, as we all kind of learn to know and love. And with that complexity naturally comes the challenges. And Istio basically tries to kind of abstract the underlying network infrastructure and focus on how services interact and connect with each other in a secure, reliable, and one of the most important things in my perspective about Istio is the ability to have very deep observability around this kind of distributed mesh of workloads and services. And from the Knative perspective, this is basically brings in a platform as a service abstractions that baked on top of Istio and brings in a lot of developer productivity into the table, and the ability to kind of operate an infrastructure that is very resembling to the Lambda and serverless as we know it today. When we talk about what's in the platform and what is the promised land that Istio basically brings into the mix, the first one is the ability around to connect multiple services that can span regions, even clouds, whether they are on-prem or on public cloud. It brings in layer 7 path-based routing capabilities that are very flexible. It kind of helps you shape based on availability and routing rules, the ability to kind of connect services. It also brings into ability to employ use cases that are relatively harder to implement around load balancing, canary upgrades, A/B testing, and everything that relies around a continuous deployment culture that normal cloud native application teams that basically drive those applications would like to employ. From a management perspective, the ability to kind of the telemetry fed from the entire service mesh fleet into a single location, and the ability to employ tracing capabilities and frameworks like Zipkin and Prometheus and Grafana basically enables us to kind of have the benefits of, or at least kind of reduce the pain that is involved around operating and building distributed systems. I mean, anyone that is running Kubernetes in production with a significant scale, or even with that, not that significant scale, but with number of microservices, it becomes an extremely difficult for the actual teams to get a handle of what is going on with the systems without having to properly bake monitoring and telemetry into the systems. And the value around the security aspects of Istio falls into three main buckets. The first one is the ability to inject service-to-service encryption, meaning that we can basically encrypt the transport between different services. So think about it as the ability to kind of inject even across multiple clouds, the TLS. Doing that by hand comes again into actually modifying code and involves a lot of challenges. It's not that it's something that wasn't done before, but Istio basically brings in some of relatively a friction-free, and I'd emphasize relatively, at this stage in time, to bring in mutual TLS into environments and kind of the provisioning of identity and secrets in a secure manner. And on top of that, one of the features that I really like is the ability to have a very deep, fine-grained API-level access controls, which brings in a lot of the kind of challenges around API-level security, and even when we think about securing east-west API interactions, this is something that brings in a lot of control and reduce the challenges or the overhead of actually implementing that into the running services. And naturally, identity-based service access control is one of the main values for that subsystem. So let's kind of try to kind of understand the challenges when it comes to microservices. And this diagram basically captures a pretty standard kind of practice of microservices, not too many of them, but at the end of the day, when we try to think about it from a security standpoint, logically we think about services as a logical unit or virtual services or services that interact with each other. If you focus on a single service, you will notice that the interaction or the kind of graph of interactions for a single service is not very complex. Normally you have few with simple services, and if you have hubs like data stores, then it might be more than that. And naturally you have third-party services that you rely on. And when you think about it from an actual runtime perspective, you can see that workloads that are not supposed to basically interact with each other can end up running right next to each other. These are the basic kind of challenges that we have today with Kubernetes, and Istio in that sense suffer or at least experience a very similar kind of challenge from a security standpoint. think about it from a compliance or a security standpoint, where you have a workload that is not fully trusted, or even, God forbid, running your customer code for some use cases for companies that are building build systems, for example, and then right next to them you have either other tenant workload. So you basically want to have kind of a handle at a very fine grain of what is happening on the actual kind of servers. And Istio tries to balance between building that in a scalable way, but on the other hand, there are still challenges that involves into where exactly those workloads are running. From kind of the architecture of Istio, we look into the main components that basically kind of help us to operate the cluster, the mesh. And the first one is kind of think about it as, just like Kubernetes has the Kubernetes control plane, Istio has its own control plane that is basically comprised out of 3 main components: Pilot, Citadel, and Mixer. Mixer basically takes care of kind of the policy decision, logging, monitoring, and Pilot basically takes care of the routing and the dynamic routing decisions. And Citadel is responsible for the identity provisioning to the workloads. Think about it as kind of an identity vending machine that provides services to the workloads that needs to run inside the mesh as they scale in and scale out. 2 important elements that are related to the security of the mesh are the entry points and exit points from the service mesh itself. And if we try to kind of think about it from a networking standpoint, think about the sidecar and the entire grid that spans the mesh as a layer 7 network that is completely abstracted from the underlying network and infrastructure and compute that runs that. And at the edge, we have the Ingress proxy that basically provides us the ability to expose services that are implemented inside Istio to the outside world. And at the far edge of the Egress proxy basically says and police which services can leave the cluster itself. And even though we like to think about Istio as kind of an incarnation of project that happened within Google and web scale companies, internally at Google, there is a link here in the slide that actually captures how Istio, in quotes, is implemented inside Google. It's a very interesting read, and I highly recommend kind of getting a snapshot of that paper. And when we try to kind of zoom in into the controlling the Envoy data plane, which is basically what drives the traffic between all the different services within the service mesh, then we look into Envoy and the Mixer as 2 components that interact with each other in the context of getting logs out of the backing data plane of Istio, getting quota limitations and enforcing quota limitations on the mesh. So think about limiting the number of connections per second you want to impose on certain services. From many reasons, you can find yourself kind of trying to limit certain services to protect other services. Authorization, which is directly related to security and how you basically authorize service A interacting with another service. So policy, the Mixer is directly responsible for that. And all the telemetry is basically being flushed into the control plane, which basically enables us to actually visualize and understand the health of the mesh and what is exactly is running inside the mesh. And zooming in a little bit further, we can see here that Envoy, which is a very kind of popular project beyond the scope of Istio. And just as a background, Envoy itself started as a project within Lyft to solve operational challenges that Lyft had internally. So it predates Istio as a platform. And one of the kind of interesting points to see that Istio actually implements what we call star DS APIs, which mainly revolves around cluster discovery APIs and endpoint discovery APIs and listener discovery and APIs, which basically enables Istio to program Envoy as the data plane and feed basically Envoy with the data to operate the mesh. One thing to note, and this is where kind of the trickier part from a security standpoint comes in, is that the auto-injection mechanism, and I'm referring here specifically to Kubernetes, is basically implemented using a mutating admission controlling, meaning that when you are deploying a pod or a replica set or any resource to Kubernetes that eventually spins up a pod, then under certain configuration, the admission controller, which is implemented part of the Istio control plane, will basically add a sidecar to the pod. And the sidecar basically takes, or the injection basically is being done in two phases. The first one is actually rewiring the underlying IP tables to kind of do a very nice trick that basically helps us to deploy Istio transparently without changing code. The first one is actually understanding that a service is exposing a certain port into the world, and then it basically programs IP tables with the exact same port. And the sidecar and the IP table rules are basically doing a redirection inside the network namespace of the application itself or the pod itself in order to route the traffic through the Envoy sidecar. There are many, let's say, value in the fact that Envoy basically see the traffic and is able to basically upgrade protocols from HTTP 1.1 to HTTP 2, or handle gRPC, or even have observability into database protocols such as MongoDB and DynamoDB on one hand. But on the other hand, with deeper observability, it comes with a price. And I often like to kind of refer to the fact that we want to use the right tool for the right task. And just like not every workload is suitable for serverless or Lambda-like deployments, it does necessarily mean that not every workload is actually a perfect fit for Envoy. And the tax mainly revolves around the network latency that is coming from the fact that we are routing the traffic and the packets twice through the network stack. So think about two services running in pods on the same server. They will traverse the network and the kernel in several times, and naturally it adds latency. So you need to think about the usage of certain services inside the mesh, whether they are latency sensitive. Some examples to that: if you have a batch processing that runs nightly or periodically, and it operates some sort of an ETL kind of workload, then it's perfectly fine if it runs inside the mesh. And if you have, for example, database that are latency kind of sensitive, and you want to make sure that they run in an optimized manner, then maybe Envoy is not the solution, or running that inside the mesh, the clustering inside the mesh doesn't really make sense. And of course, and this is something that, as a security vendor, we often being asked about, what is the overhead of memory and CPU your product have? Think about Istio. We are basically not doubling, but adding a lot of CPU and memory pressure on the underlying infrastructure. So there is direct cost associated with the infrastructure. But then again, trying to look on the positive and the bright side, the observability part in distributed systems is something that takes a lot of human effort to get right, and Istio brings an immense kind of value around that. So just to give you an example, and here we kind of take a more security kind of wearing the security hat. we saw in the previous slide that basically the injection of the sidecar involves rewiring the IP tables and basically enabling to route the traffic from the application into the proxy. There are several network protocols that doesn't really go through the Envoy itself. So if you try to think about Envoy and Istio as an end-to-end security and isolation implementation, then it's not the right way to think about it. Think about it more as in service-to-service access control. But when it comes to the underlying infrastructure, if you're running your pod as root, which is not the recommended practice, but it's the default behavior of Kubernetes, for example, you get the ability to add users in a specific user ID that Envoy use. And at the moment that you spin up a shell under the same user ID, nothing really goes through the Envoy proxy, and it is not subjected to the cluster or to the service mesh policies. So when it comes to environments that are regulated or are sensitive around specific challenges around isolation, then clearly you need to think about securing your service mesh as kind of securing the mesh itself, but also taking care of what's the underlying infrastructure that it's running on and taking care of that as well. And we see this trend for quite a while, that the application and the underlying infrastructure converge, and functions are kind of the ultimate conversion or convergence of this kind of trend. But you need to make sure that you have kind of security layering and isolation stacked from the application to the workload, to the underlying node. And sometimes if it's running on public cloud, then you also need to take care of the security groups in your public cloud. And we will see a specific example on that exactly. Other kind of escape methods, think about IPv6. Pods can interact on a very low level kind of protocols on east-west communications. Neither IP tables nor Kubernetes, and specifically Envoy as well, are not even looking at those protocols. So from an attacker standpoint, these are quite legitimate communication channels that attackers can actually interact inside your operations. In order to take care of the challenges around, are we running with our pods configured correctly? Pod security policies are coming to the rescue and can actually enable you to run, or at least get a handle of not loading pods with root permissions. So meaning that you're running your pods rootless. And then this escape method is not really exploitable. But then again, it sometimes will require some dev efforts to get this right. So when it comes to performance and the service mesh, I took here a slide example of Cassandra. So think about Cassandra as just another service that should run in your service mesh. And here specifically, we have a data center aware Cassandra deployment, which basically spans two different data centers. One is running on your favorite cloud provider, and then the other one is running, God forbid, on-prem. And the data center replication that Cassandra basically takes care of is something that may run inside the service mesh. It can be provisioned using the control plane and establish a secure kind of end-to-end connection between the different endpoint in the Cassandra cluster. But when it comes to the cluster that basically drives what's inside a specific region, it may very well not make sense to employ the service mesh between the Cassandra nodes themselves. So again, in the spirit of use the right tool for the right task, sometimes it makes sense to actually have a hybrid deployment. And when it comes to operating workloads that are not part of the mesh, it simply mandates that you think about security as not just using Istio network policies, but rather think about employing the full stack of security capabilities that the Kubernetes platform as a whole brings into the table, and kind of think holistically about those challenges. So a little bit about the notion of zero trust, and it's an often used term in many contexts, but at the heart of it is bringing security into the network and into the application mesh. So traditionally, we kind of try to think about our deployments as let's kind of hedge the perimeter, whether using firewalls or whether we considered our load balancers as kind of the edge that separates our internal deployments and infrastructure from the rest of the world. But then again, when it comes to these highly distributed environments and the fact that sometimes the software supply chain is the one that basically brings in vulnerabilities into, or real threats into deployments, then we need to try to think about the threat model differently, in the sense that what's your end game if you already have someone inside your environment? Will you be able to detect that? Will you be able to prevent that? And when we try to think about going the application segmentation or implementing a fully kind of zero trust deployment, it makes sense sometimes to kind of do that in a gradual manner, meaning that you start with creating boundaries around some of the more sensitive tiers or microservices. So think about like data services that are running inside the service mesh. So try to think about segmenting those and building a zero trust notion around those. And by zero trust, I mean zero trust at the API level, zero trust at the network and infrastructure level that runs those workloads, and the ability to kind of implement those segmentation and zero trust concepts enables us to limit, from an attacker standpoint, the ability to do lateral movement and the ability to actually identify lateral movement. And it's quite important to note here that identification of such, in the presence of such an attacker, can come from signals that are being surfaced from the running infrastructure. So if, for example, you are using network policies, whether Istio or Kubernetes, and some traffic is being dropped and you are not monitoring those logs, then you are basically missing part of the picture that is in front of you. So try to balance between employing security tools and actually monitoring them, and not just relying that they are there and things are nice and clear. But having said that, zero trust is a great start. It's a good start, but it's not enough. When we think about the full application deployment lifecycle, there are many, let's say, hygiene checks and security testing that we can employ early on in the development phase. So even in test, misconfiguration and even security configuration drifts, or even bad package from an NPM repository being hacked by someone, is something that we can detect early on in the deployment pipeline. So essentially, we don't really want to meet problems at the production side, but rather try to kind of get ahead early on in the game. But for that, you need to basically think about security and employing security products or subsystems early on in your kind of journey into Istio, journey into Kubernetes, or even both. And the other part, which we'll look into later, is what's your end game as far as threat protection, exfiltration data through the application that are running inside the mesh. What do you think about scanning, spoofing, those hardware vulnerabilities, like how basically can you get a handle ahead of the attacker on all those threat vectors. And even with the recent RunC vulnerability that we all experienced, there is a lot of kind of challenges around getting those complex systems the right way. So going a little bit deeper on the zero trust and the application segmentation, we want to try to think about policy mixer as the one that decides on whether service A can interact on service B based on configuration, which is a pretty powerful capabilities in respect to what Kubernetes has to offer, which is a label-based approach. We can inject TLS end-to-end across the different services, and Istio basically takes care of all the lifecycle management of secrets and certificates, which essentially it's relatively heavy lifting when you try to build it on your own. So the platform out of the box brings in a lot of good know-how and modeled into APIs and configuration that gets you to run with that. When it comes to kind of, and here we kind of dive into how we configure Ingress and Egress policy. So in Istio, the gateway resource basically represents the ability to expose services to the outside world. And essentially, once they are in the mesh, then the mesh routing takes care of who's picking up the API calls and how they traverse the different services east-west. But when it comes to egress policies and definitions, so we basically try to think about it as defining a service entry, which is a very similar concept to what endpoints in Kubernetes represent, meaning that you represent within the cluster or the Istio service mesh resource language an external service, and then you can define route using the virtual service resource on the left-hand side that represents a routing rule and the ability to kind of say that if you try to access google.com on www.google.com on HTTPS, then all the wiring within Istio is taken care of. And it's a pretty straightforward in respect to previous API versions within Istio, which were slightly more complex. Do note that despite the fact that it looks kind of straightforward, we are looking at the networking APIs at V1 Alpha 3, so it's still early stage on the kind of API maturity level, but despite that, it looks like this part of the APIs has a very solid kind of concepts and revision compared to the previous API. And when it comes to kind of the superpowers of Istio, and when we think about building role-based access control systems into our own kind of applications, it's extremely complex to get it right. And Istio, in a very similar way, for those of you who know Kubernetes RBAC resources, so Istio pretty much gives you the ability to associate RBAC definitions, which basically captures the notion of who is allowed to do what under which conditions. And in this specific example, we can see that we enable RBAC on a specific namespace. And within that namespace, we can see on the upper resource, the service role, we can basically say on the condition of V1 and V2 of the product service, we allow the read-only access. So read-only basically is represented by get and head HTTP verbs. And we bind those rules into the underlying service, which is basically represented by the name that we see here. And the source is being limited only to those users that are already authenticated in the system, and this is captured by attributes that exist inside the HTTP headers. One thing to note about it is when it comes to other protocols, such as GraphQL, for example, which is a very popular way of building kind of interaction between systems and front ends. Those APIs have slight challenges. Think about other protocols like Kafka and databases, then it's not, let's say, mature in that sense. And then again, those APIs are right now at V1 Alpha 1. So take that as kind of an asterisk at the top of it, whether this is ready for production or this is something that you want to basically wait and give it more kind of runway to mature. So let's take an example. So we've seen so far multiple kind of segmentation constructs, starting from API level access control, role-based access control, the ability to inject MTLS into the system. And in this example, let's see actually how where we need slightly more than that and why segmentation is extremely valuable. So this was a real exploit that happened last year. This had happened on Shopify Exchange. It's a small service within the Shopify application that basically enables users to upload screenshot of a product. And luckily for Shopify, I would say, this exploit was found by a friendly hacker that basically did kind of a responsible disclosure to Shopify through bug bounty. But essentially they had in one of their services an application level vulnerability that basically enabled an attacker to manipulate the system and create a server-side call as a response to the manipulation that the attacker did. They basically did a direct call to the metadata services of the underlying cloud provider. Those are weird addresses that start with 169.254, etc. And in GKE specifically, the bootstrapping of the cluster is actually happening using the metadata APIs and the embedding of secrets within those APIs. The attacker was basically able to retrieve the private key and the certificates of the node. He manually edited the kubeconfig on his machine, and he basically had a complete access to the cluster. So think about Istio or Kubernetes for that matter. The question is, will those elements would be enough to block this type of an attack? Or what would be that security monitoring in your environment that will help you kind of detect this type of attack? And the question is, isolation would be definitely the right tool for that. So I'm not going to go in depth into the Kubernetes network policies, but I highly recommend employing both Istio network policies and Kubernetes network policies, which basically gives you kind of a full stack of defenses in terms of isolation and limiting what the attacker can actually employ in the system. And as challenging and maybe not challenging those employing network policies may be, the reality is that from a segmentation standpoint, you can think about it as you can use Kubernetes network policies in combination with Istio network policies. You can maybe manipulate the Kubernetes scheduler to actually separate physically some services from other services using taints and tolerations, which essentially can give you physical isolation at the node level. But sometimes it makes sense to employ multiple clusters to create a stronger isolation. In this example, we can see that in a commerce application that is PCI DSS compliance is required. In such case, it makes sense to deploy 2 Kubernetes clusters, run the Istio control plane on a separate environment, and have the Istio kind of in-cluster components available for the provisioning and the interaction with the control plane. But at the end of the day, we want to kind of deploy the cardholder information or the workloads that handle the cardholder information on one cluster, and physically segment that using cloud policies or security groups or firewall policies. And then the rest of the workloads can be run on the other cluster. And if you need to run it on multiple regions, then you can basically replicate that pattern across more regions, and you can essentially get an isolation that is compliant. One of the challenges with Istio is that if you do not have a control over the underlying infrastructure, then it makes you kind of, it makes challenging for you to identify where the data is and where the data and whether the access to the data is fully controlled. If you assume your kind of monitoring and audit trail based on just what's happening in the mesh. Naturally, there are challenges of operating clusters separately in such ways that there are compute resource overhead associated with that. There is an operational overhead that is associated with that. So end-to-end, it does give you the ability to run in a compliant manner, but on the other hand, you need to take care of a more complex infrastructure underneath you. So just to give you the sense of what is the anatomy of an attack, and we talked about so far how network policies across the full stack application layer, the network layer using the platform constructs, or even third-party products that employ access controls. So normally for an attacker to kind of mount an attack, it starts with reconnaissance. You collect information on how you can get into the system. Once you are inside the system, and think about it as either an open source component that end up in a container that is being deployed using your pipeline and is introduced into the environment, or something that hits your service, just like we saw before with the Shopify example. And at the end of the day, once an attacker is in, it is possible, even using all the policies that we saw so far, the ability to escape the mesh and even the Kubernetes cluster. So this specific attack is actually leveraging some weaknesses, inherent weaknesses that DNS has as a protocol. And it basically creates the ability for an attacker to create an infiltration point that interacts with a remote location and can drive data outside the cluster. And every cluster basically have the DNS discovery as kind of the backbone of the service discovery. So tunneling essentially leverage DNS by embedding messages of, let's say, SSH protocol or whatever, and leveraging the DNS transport and message exchange as the underlying mechanism for delivery messages of the SSH protocol for that matter. And then from a security standpoint, we simply bypass security boundaries that we think we have using something that is inherent into the system. Protection against this type of an attack is an extremely challenging in the sense that we have a lot of moving parts running in the system. So one of the challenges, or the challenges around that, mainly revolves around the ability to have high resolution monitoring and deep packet kind of an application aware inspection of what is interacting with who within the workload level, and then try to kind of build a bigger picture that understands the context of microservice. So we can think about it as detecting anomalies between workloads within a certain service. And once you have that, it creates kind of a basis for which, profiling and the ability to detect deviations from this profile is something that drives you into the ability to detect this type of attack. And it involves the ability or requires actually to deploy security agents that are intimately weaved into the system itself. And when it comes to higher level protocols that Istio network policies provide, think about application level attacks and ask yourself whether Istio networking policies and role-based access controls are something that is sufficient enough to detect API exploitation. And even though Istio itself do provide zero trust API access level controls in a very fine-grained manner, it is challenging to manage that. It provides a very good isolation, but at the end of the day, this is not enough to just kind of drive that. So with that in mind, I think that to summarize, complexity essentially is the worst enemy for security, and both Kubernetes and Istio are an extremely powerful systems. To get them right requires oftentimes deep understanding of what those systems are doing internally. And the fact that we have multiple stakeholders that are driving this, the ability to kind of have, and we call it smash ops, mitigating those challenges, it's a collective effort. It's not just a security team effort. DevOps are definitely the glue layer between dev and security. And looking at the kind of full threat landscape and understanding the challenges, and it is okay to kind of say, prioritize what do you want to tackle first, and then start with the big rocks, but keep doing those at a continuous kind of approach. Start as early as possible and make sure, hygiene-wise, both Kubernetes as the underlying backbone of Istio and Istio itself are well configured, and then take care of the anomaly detection and threat protection using deep security controls. So with that in mind, I think it covers the kind of content and that I want to cover, and we can move into, I guess, some questions.
Awesome. Thanks, Dadi, for the great presentation. So let's get to some questions now. If you haven't already dropped a question in the Q&A box, that is at the bottom of your screen, and we'll get to as many as we can with the remaining time. So this first one is back from the beginning, but can you just clarify that when you're referring to identity-based service access control, what exactly that is?
Sure. So when we think about services, we normally associate with the service a domain endpoint. And by referring to the identity is the ability to provision an identity, a domain name to that service. And within the Istio mesh, Citadel is the one that is required or provisions that. And once you have that, we can provision the certificates for the access control and the TLS authentication between two services. So essentially, it's mainly around getting your FQDN and provisioning a certificate for that. Once you have that, interaction between services can be authenticated using the server name identification that is embedded inside those provisioned certificates.
Great. And then, so is Istio Envoy altering the IP tables itself, or just leveraging and communicating with them?
So the injection, so Envoy itself doesn't change the IP tables itself. The provisioning process or the injection of Envoy rewires using injection of IP tables rules. And by doing that, it takes care of the traffic that the application basically passed through the Envoy itself. So Envoy itself makes certain assumptions, and based on those assumptions, it takes care of the fact that traffic passed through it, and it understands what's behind it, and what's the upstream and what's the downstream, and takes care of the routing based on the APIs and the discovery APIs that implemented by the Istio control plane, and specifically Mixer and Pilot.
Awesome. And how are the calls within Envoy being secured?
So assuming I understand the question, so Envoy itself, and it really goes through a rigorous kind of security testing and fuzzing. But at the end of the day, Envoy itself is just any other application component that potentially can have vulnerabilities. But inside Envoy itself, it relies on filtering mechanisms, and there is an internal implementation that follows security best practices and security best practices from a testing perspective. So assuming I understood the question, that's kind of the perspective on that.
All right. And what is the recommendation around how to separate policies between Kubernetes network policies and Istio?
So that's a really tough one, because at least from our perspective, once you start to employ both Istio policies and Kubernetes policies, you end up having gigantic size or number of YAMLs that tries to capture policies, and over time, we add more microservices, and we really like this kind of the velocity that it gives. So I think this is something that oftentimes we run into customers that actually ask for help with managing the complexity. And I think a good start would be getting, at least for Kubernetes, a very solid labeling strategy. Try to kind of not overdo implementation of the policies, and start by building some tiers and building policies around that. Same goes with Istio. See that you do not go too further south in the complexity. And then, visualization is something that always helps, especially around policies.
Great. So another one here. How does Istio handle identity propagation? So let's say the end user is invoking service 1, which in turn invokes service 2. How can the end user identity be made available to service 2?
So I think right now, as far as, and maybe this is something that changed recently, it's not being handled. And the fact that it's not being, so the user identity is not propagated all the way into the internal services, this is something that actually creates kind of challenges where you lose the original context from which a service call was made. So I think that one of the changes, if those were not already done, would actually be able to kind of propagate user identity all the way to the, let's say, internal services inside the mesh. But it's an excellent point where a lot of privileges escalations had happened. Even the recent Kubernetes one was actually following a similar line where internal components weren't aware of the originating call permissions. And it's an excellent comment, and I certainly hope that Istio will get this thing right, rather than having the application owners implement that in code.
All right, another one here. Is there a way to find an overlapping or conflicting RBAC rules across a namespace?
Not as part of Istio. You need to have like an analysis on top of whatever Istio is giving you. But out of the box, the tools that exist within Istio, you don't have that.
Okay. And are there any UI tools for managing Istio policy creation and validation?
Not that I am aware of. I think this is where actually vendors come in and try to kind of ease the pain of a powerful platform. But Istio by itself has visualization of the mesh itself. So, you know, trying to kind of zoom in on a certain service and then understanding the ingress edges and the egress edges gives you a good sense of what the policy should look like. Challenge is, how do you maintain that over time as developers add more service-to-service interactions? And that's a challenge.
So can we plug in custom authentication policies in Istio?
So there is the ability to add external authorization into the mixer. You basically can add a plugin to Mixer, and based on that, you can implement external authentication and authorization machinery. So in that sense, I think that Istio control plane, we are going to, and a lot of it is already there. It is extendable in the sense that you can customize it and kind of tailor-made it to your needs. And I think a lot of the good work that had been done with Kubernetes and still being done, also kind of that spirit is being followed by the Istio teams.
All right, let's try and get to one or two more here before the top of the hour. Can Istio run and integrate with an existing deployment which has Keycloak already installed and RBAC configured?
I couldn't hear the last, so can you repeat the question, please?
Yeah, sorry about that. Can Istio run and integrate with an existing deployment which has Keycloak already installed and RBAC configured?
So I don't know specifically about Keycloak as your kind of identity provisioning. I will guess that there should be, or there might be, a plugin that actually enables you to kind of connect the identity provisioning part with Keycloak. But then again, as far as the RBAC goes, I'm not sure this is something that is actually can be connected. But I will say that specifically, it's really hard for me to give like a precise answer here.
All right, so we are at the top of the hour. So what I'm going to do is I'll make sure any questions we didn't get to, we get you answers after the fact. I know Gadi's email is also on here. So thank you everyone for those great questions. Once again, the recording and slides will be online later today, and the link will be emailed to you all directly. So you'll have all of that. And thank you all for joining us today. We look forward to seeing you at a future CNCF webinar. And thank you, Gadi, for the presentation.
Absolutely. Thank you guys for being with me.
Awesome. Have a great day, everyone.